Let's begin. Today's May 27th, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and it's 5 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 5 criteria cards. Criteria card 6, 13, 14, 18, and 19, and he uses the purple verification cards. And above you'll find the unique identifier for today's puzzle, which you can always go to turingmachine.info to get the details. Let's go solve. So on the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. And the bottom row, we've got criteria card D, and finally criteria card E. Criteria card A looks at the middle digit, the square digit, and will let us know whether that value is an even or an odd digit. Criteria card B will compare the middle and last digit, the square and circle, and let us know whether the square should be less than circle, should they be equal, or should square be greater than circle. Criteria card C will let us know which is the absolute smallest of the 3 digits. Should the triangle be the smallest? Should the square be the smallest? Or should the circle be the smallest? Criteria card D will take the sum of the 3 digits, triangle, square, and circle, and will let us know whether that sum is an even quantity or if the sum is an odd quantity. And finally, criteria card E will take the first 2 digits, the triangle and square, add them up, and compare the sum to 6. Should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Remember, we're looking for a unique 3-digit code that will meet all of the above criteria. And we're going to start off with our proposal of 314. So the first thing I want to test is criteria card A. I want to know if that middle digit is an even or an odd. Okay, so the Turing machine responds that it approves of my proposal. Notice that my middle digit, I chose a 1. So basically the Turing machine is telling me, yes, it agrees that that value should be an odd integer. So let me put that in my notes. So I'm going to say that square is an odd digit. And so that means that any even are invalid. So I'm going to come up above here and cross out all of the evens. So I'm going to cross out 2 and 4. Okay, next I want to check whether the sum total is an even or an odd value. So I'm going to test criteria card D. Okay, so notice that the Turing machine does not approve of my proposal. So if I go back and look at my proposal of 314, if I add up the digits, so 3 plus 1 is 4, 4 plus 4 is 8. So my sum is 8, and the Turing machine does not approve of that. So that means that the sum total should indeed be an odd value. So let me write that in my notes. So triangle plus square and circle, that sum should equal an odd. Okay, so again, my proposal summed up to be even. Turing machine disagreed with it, so it's got to be odd. Okay, so what does that tell us? So if the sum is the sum of the 3 digits is an odd, that means there are 2 possibilities. It could be that either they're all odd, right? If you add up 3 odd values, you're going to stay with as an odd. But equally, you could have 2 even values and then have an odd. So that means that we have, I won't call them pairs. I don't mean to imply that they're duplicates or they're equal, but you have 2 evens or 2 odds added to an individual odd. So that's at least what we're looking at. And right now we've got that, we know for sure that that middle digit, the square digit, is indeed odd. Okay, so let's see, what else can we test? We've got a couple of options. We can compare the middle and last digit. We can figure out which is the smallest digit, or we can see what the sum is. I believe it's really a toss-up, but I'm going to go with testing criteria card E, seeing what the sum is. So let's see what E tells us. Okay, so the Turing machine does approve of the sum. And so again, if I look back at my proposal, if I'm looking at the first two digits, triangle and square, if I add up those digits, 3 plus 1 gives me 4. That sum is indeed less than 6. And that's what the Turing machine is telling me, that my sum of 4, since it's less than 6, that's what I should end up as my final solution, something that's less than 6. So let me write that down in my notes as well. So I'm going to say for criteria card E, that triangle plus square needs to add up to something that is less than 6. Okay, so let's take a look and see what we have. Since triangle, we really haven't done much with triangle. It's wide open. It can be anything between 1 and 5. But if I want a sum to be less than 6, triangle can't be 5, right? If I add up 5 to all of these values for square, they all will be either equal to 6 or greater than 6. So that means that 5 is not a valid value because it'll, break that rule of the sum having to be less than 6. So it can't be 5, and for a similar reason, square can't be 5 either, because again, if 5 were the square, 5 would be added to any of the triangle values. That also would be at a minimum 6. 1 plus 5 is 6. Anything bigger than 1 will give me something greater than 6. And so the square 5 also needs to be crossed out. Okay. So anything else? No, I don't think so. 4 is still okay because I could add it to 1, and then 3 has a lot of possibilities to 3 and 2, 3 and 1, and so is 1. So yeah, so I think that's it for eliminating any possible values. And so that was criteria card E. And okay, so now we're kind of going to the phase of trying to construct a good second proposal. So I have not tested criteria card B, comparing the first two digits, and I don't know anything about the smallest one, smallest value. So just from the get-go, since I have eliminated, several values from square, it's possible that square could be our smallest value. Remember, going back to criteria card D, we're looking at two potentials. We definitely know we need an odd, but the other two could be evens and an odd. And we do have this equal comparison for the middle and the last digits. And so perhaps we are dealing with maybe a pair of odds since square is odd. That's one possibility. And so let's see, what could that be like? Well, notice that if they are to be equal, I only have two options, 1, 1 and 3, 3. Now, it can't be 1, 1 because remember, we are dealing with a value that's absolutely small, smaller than the other two. And so if I'm picking 1, 1, obviously 1 is not less than itself, and there's nothing smaller than 1. So if it is going to be equal, it would be 3, 3. Okay? And if it is 3, 3, obviously the smallest would have to be 1 or 2. Now, and since I do have two odds, 3 and 3, the only possibility would be a 1. Because even though 2 is smaller, to have that end sum of it being an odd, I have to have a third odd. And so 1, 3, 3 is a potential. It sort of fits all the boxes, but is that the answer? I'm not sure. Could there be other alternatives of comparing square and circle that would yield that as well? Remember, we are, the only other possibility then would be if the middle is the odd, then triangle and circle would have to be the evens. And not to say that, again, they don't have to be equal. They don't have to be equal. So we could say it could be 2 and 4. Well, let's look at it this way. If it were to be 2 evens, then I guess they potentially could be equal, right? We could have 2, 2, and then the smallest one would be square. But we already did I guess I had not considered, I said 1, 3, 3. Oh, but these are two different, this is the second and the last. These two would be equal, but with that, could I somehow get it to be 2, 1, 2? Square would have to be the smallest, and that would mean that I couldn't be adding 4 to it. Could I actually have 2, 1, 2? If I compare square and circle, well, square would have to be greater than, but would that make sense? Not sure. Okay, well, we got to try something. So I think I'm going to go with my initial, guesstimate of 1, 3, 3, and let's see, how far we get with that. Okay, so since I did say they were equal, square and circle, let's go ahead and test criteria card B. Okay, they are equal. Okay, and remember I did say that we have to disqualify the 1, 1 because there's nothing smaller than that. And the only thing that's left to be equal are the 3's. So it has to be 3, 3. And therefore, again, because of D, triangle would have to be 1. So let me go ahead and write down my notes for B, since the Turing machine did approve of that. And we will say that square is equal to circle. Okay, we know that they are equal. And again, we have to disqualify the 1's. So that means that the only pairs that are equal are the 3's. So let me go ahead and cross out the 1 here. And then let me cross out everything but the 3 for circle. Okay. And so we do need a smallest value, which we haven't tested, which is criteria card C. So it obviously can't be 4 or 3, because 3 is not less in itself. So again, it's only between 1 and 2. And because of the sum having to be odd, it has to be a 1. So that means that everything gets crossed out but the 1. And so we're going to deduce that the smallest is a triangle. We actually don't have to test, but I will put down in my notes here that we're going to deduce triangle is the smallest. Okay, so I'm proposing that our solution is 1, 3, 3. Okay, and just so quickly, yes, the middle digit is odd. The second and last are equal. That's correct. We're deducing that triangle is the smallest, and which would force it to be a 1, because the sum total has to be an odd value. Notice that 3 and 3 gives me 6. I have to add an odd to it for the total sum to be odd. And of course, 1 and 3 does add up to be something that's less than 6. So awesome. It looks like we only had to try 4 different tests. And so let's go to turingmachine.info and verify our solution. So we have 1, 3, 3, and my button is down here. Verify. Okay, yes, we got it. And so I do feel very confident that we did beat the machine, since we did it in less tests than there are criteria cards because of our deduction. But let's go ahead and type in ADE for the first turn. ADE, and I believe the D was incorrect. Yes, and B was correct in the next turn. And so we only tested 1 item in the second round. And so yeah, look at that. So we did it in 4 questions. The Turing machine did it in 6. So our deduction really paid off in this game. And so this was somewhat easier. I was concerned when I saw some of these cards. I was concerned that it was going to be quite a lengthier puzzle, but this deduction really paid off. Okay, well that does it for today. If you liked today's video, please give it a thumbs up. If you saw something that I missed, did I make a mistake, or if you have a general suggestion, please leave a comment. And if you don't want to miss the next video, make sure to subscribe and be notified. Well, until next time, have a great one.